Okay.
Okay, I liked everything about the week. I especially liked the people I met here, the facilitators who had a lot of enthusiasm and encouragement and great ideas that I will use in the classroom or I'll figure out how to adjust to use with my middle school students. I like the teachers I met here. I made some new friends, some new resources throughout the state of New Jersey. All I can say is good things about this week. I've learned a lot of hands-on activities. I did a lot of hands-on activities. And even the guy holding the camera, I wish him a lot of luck in his first year of teaching. And if there's any encouragement I can give him, I hope we stay in touch. I'm sure we'll stay in touch. Okay?
Yes, we will.
All right. All right, Brian. Thank you.
Thanks, Mike.
For it because it's a different situation. Now, this particular concrete is 3 parts cement, 2 parts gravel, sand, and 1 part gravel. Okay. So we're going to try it with 1 brick to start with. And this is more or less, now this is classified as a destructive test. Because when we're done, it's done. Okay, as opposed to the unhomogeneous you just did, that's a non-destructive. So X-raying is a non-destructive in theory anyway. So we're going to put some weight on here. I would need to have somebody help steady these or add bricks or both. Okay. Okay, Steve? You going to be our steadier?
He's a karate player.
Okay, so I told you 2 of them.
I'm not adding any up or down forces, just steady. For those of you worried,
We're watching this, Steve.
You're trying to sabotage our concrete.
I'm breathing down on it.
How far up you
Keep it with your forehead.
You're right.
Oh, jeez.
They welcome.
Oh! Emma?
So I withstood between 3 and 4.
Here, where's the Nars, all right? Where's the Nars?
Well, you got me jumping on the video when it broke. So the video went. Yeah.
What's that?
That one's 3 gravel, 1 cement, and 2 sand. So they
It's the reverse.
You want to be the steadier?
I'm writing this down.
Go ahead.
That's got to be a good one. It's got 3 gravel. That's a good. That's the
You want
deal.
with the opposite.
Sand, gravel,
I'm just
Steady.
steady. Just third hand here.
Yes.
Please.
Steve, breathe hard.
Okay.
the standard.
Just 1 cement.
Back.
How's that? Centered this way. Centered.
Right, but the piece of
Yep.
wood.
Okay.
So the better we cured it,
Oh, too bad.
Wow, that was heavy. Okay, now let me point out a couple of things to you before we go on. Remember that this is cured how many days? 4. So that may be a major factor because the general rule of thumb is that a month is 90% strength. A month to get 90% strength. No, because there are arguments, but the general feeling of most is that to get full strength you need 30 years.
30 years?
So the 4 days over. No, you're lucky to be 50% strength.
Right.
So after 4, so there's a lot of variables going on here in terms of 4 days. The other thing is that we have some irregularities to this, and we may be hitting a stress point due to some irregularities. Concrete is really strongest. I mean, the place where it tends to break is in the bond between the gravel and the cement. The main strength is from the particles, the gravel and the cement. But you can have really weak gravel. It becomes fun. You know, it will shatter fairly easily. the quality, but they also will sell 5 bags cement and 5 bag concrete and 6 bag concrete. And so, and the 6 bag concrete means 6 bags of cement per cubic yard of concrete. Costs more than 5 bags. I don't know how much gravel and sand they put in it when you buy it ready mix, but most people want to do it 3 gravel, 2 sand, 1 cement, and it's a little water, and you can mix it up. Water probably is a major factor that's affecting us after 4 days, because those chemical reactions that are going on in there are varied by the water. But anyway, we can get a variety of and you can go ahead and guess yours.
This is
Yeah, this is okay. I wanted to talk about the thing that comes online.
Okay.
This is a teaching unit, really, on concrete. And it's from MII, which is the Mineral Information Institute, www.mii.org, and it's on the board already at the top. And, you know,
Now, you have a Hershey bar with nuts in it.
Andrew knows.
Would it be stronger than the one that's just plain chocolate Hershey bar?
It's a composite, obviously.
Don't
No,
burn
serious.
breath.
Because when you break biological membranes, you do freeze fracture. And you go around like the mitochondria. That's why you go to surface detail.
You want to go in the other direction?
Yeah, he started turning the block. That is like the weak spot. I want to have those air holes. Build my concrete.
Pretty good. Okay, go ahead.
Well, we've been attending this material science camp for teachers, and my purpose for coming was so that I could get some good hands-on experience. As you can see, I got a lot of good hands-on experience here. And if we enjoyed doing this, which we did, okay, I'm sure the students will, so we're really going to be bringing a lot back to the classroom. Not just, the doing the thing, but also so we can explain it to the children, and so that they have a better feel for science. And it's very applied knowledge, which I think is great, because when you're teaching, you want to tell them about their world, and because then they carry that with them through life. So,
I also learned a great deal here. I had a small amount of knowledge on material science, and but I didn't really know how to bring it to the kids. And because we have constraints with our Regents curriculum, the way that it was presented, you could put it into any state and present this with any curriculum. And I really thought that I received a great deal of knowledge on how to explain some very difficult ideas to students in an easy way.
Great, thank you.
Great experience.
Glad, thank you.
Thank you.
Okay, recording, go ahead.
Okay, I'm Gary Sikora from Latter Day High School. This was an excellent workshop series. It showed a lot of interesting demonstrations and gave the principles of understanding of composites, metals, polymers, and other things. And it's a great course, great ideas for demonstrations as well as labs for general science students or more advanced students. Great job by everyone.
Thank you very much.
Well,
I don't know who wants to go first. Okay. Go ahead.
I learned a tremendous amount of information from this program that I can bring back to the
Sorry, I can't hear
classroom.
you. Go ahead.
Can you hear me? I was saying, I've learned a tremendous amount of information that I can bring back to my classroom, and it's all hands-on, practical information. I love to introduce new topics by doing a demonstration or making it practical so everyone can relate to the concept, and then I go into more specifics. So this has been a wonderful experience because the master teacher were so knowledgeable and so helpful. They were able to help us relate it to the classroom.
Great, thanks.
And I already had a large background in materials science and engineering, but this program really helped me to see ways that can be brought to the classroom so the students can see that these various topics in action. Because that's not the way I learned them, but it's the best way to bring that knowledge to new students. So I'm really glad that I came to this program.
Great.
Oh, no, I was going to say something else.
Go ahead.
What do you want to know?
Whoa. What did you learn stuff you can take to your classroom? Actually, you teach special ed kids mostly. And if you could mention that, like, and if you can, that'd be really good.
Yeah, absolutely.
Okay.
The whole course was really of extremely high quality, I thought. As far as the ideas, physics and chemistry classes in specific would benefit hugely from this type of stuff. Also, another idea that I have is that we do teach special ed kids and we provide reward systems for them. One of those is an art club. And a lot of these activities like metal enameling and the production of these materials could really fit well into an art club. And these kinds of rewards would excite these kids. They would want to do these projects. And you can integrate all the science and the actual theory behind these ideas to actually help them learn something as well. So I think this kind of thing, especially for non-traditional learners who don't work well out of a book and don't want to take notes and don't want to write things down, if you get their hands into this stuff, they can still catch on to the ideas and gain a similar benefit to the sort of traditional learners. And so in that sense, it's really, really useful.
Great, thank you.
I enjoyed the week immensely. The amount of hands-on activities were great. I teach ESL, special ed, and general ed students, so who are always asking, how does this impact me? Why do I need to know? Now I can give them a concrete, no pun intended, example of each of the different things. And I don't know that I ever thought about solids just in those 4 categories before, or really had a very narrow definition of each of the 4 categories. So I just perceive us the whole year integrating this into each thing we do can now carry that chemical theory that we're supposed to be teaching into more hands-on and real-life experiences for the students.
Great.
And for the ESL kids who come from other countries and materials aren't as abundant as they are here, and this kind of you could bring into the whole socioeconomic, political issues of what makes the America kind of compared to their countries.
Okay.
Hi, I'm Cindy, and I do work for the Department of Human Services. I teach in the different schools. They're alternative schools for special students, and I've learned a lot here at Materials Camp that I hope to bring back to these schools and to the teachers there too, to help our students learn with these materials.
Great, thank you.
We enjoyed the program. It was highly professional, packed with knowledge, and we learned a lot. And we needed probably a longer time, but we enjoyed it. It was useful for all of us.
Okay, thanks.
By example, is that what you're saying?
All right, go ahead.
Hi, Steve Baskin, Hillsborough High School, and the materials camp was the best workshop I've ever attended. The demonstrations were great. They were all hands-on things we can do in the high school classroom. They were all with materials that are very obtainable at either Science Supply or Home Depot. And I learned a lot. I didn't know too much about composites. I had heard what they were, and I learned all about composites in the workshop. And we got to cast metal, which is something I always wanted to do, and I saw that we can cast metal in my high school lab. We don't need to have a metal shop, and these things that I learned are going to be dragged directly into my existing physics curriculum, and I'm looking forward to it. The support staff and the instructors were all pleasant and knowledgeable, and it was a lot of fun as well, and sometimes science should be just fun too. Thank you.
Thank you. No?
You can leave me out of it now.